this episode, we're going to compare two automation styles that can both deliver results, but they deliver different kinds of control once you're operating at scale and under real-world pressure. Agent-based automation uses a small, persistent software component on each managed system, and that component can receive instructions, report status, and sometimes enforce a desired configuration continuously. Script-only automation, sometimes called agentless automation, relies on running scripts or remote commands from a separate control point without installing a persistent helper on the target. Beginners often focus on which option feels simpler to start, but practical operations cares more about what happens on the 10th rerun, during partial outages, and when multiple teams are making changes. Control in this context means knowing what was applied, knowing what is happening now, and being able to steer systems back to a known good state without guessing. When you understand the control trade-offs, you can choose an approach that fits your environment instead of fighting the consequences later. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good first step is to define what an agent really is in operational terms, because the word can sound vague or even suspicious if you've only heard it in security stories. An agent is a long-running process that lives on the managed machine and acts as a local representative for your automation system. It can maintain a secure relationship with a controller, collect data about the machine's state, and apply changes using local access. Script-only approaches skip that permanent footprint and instead connect to the machine only when needed, typically over a remote management channel, run actions, and then disconnect. Both models can be engineered well, but they produce different kinds of visibility and different failure modes. Agent-based systems tend to be better at continuous awareness because they're always present, while script-only systems tend to be better at minimizing what is installed on targets. The control question is not only who can change the machine, but also how confidently you can confirm what the machine is right now. Control starts with identity, because any automation approach must answer who is allowed to do what, from where, and with which privileges. In agent-based models, the agent itself often becomes a managed identity on the machine, and the controller needs a trustworthy way to authenticate to it and authorize actions. That can provide strong governance if the identity is scoped and monitored, but it also means the agent is a high-value access pathway that must be protected. In script-only models, control depends heavily on the remote access channel and the credentials used to connect, which can be clean and auditable when designed well, but can become messy if teams reuse accounts or scatter secrets across many runners. Beginners sometimes assume agentless is automatically safer because it installs less, yet a script-only system can still be risky if it relies on broad credentials that can touch everything. The control outcome you want is least privilege with clear accountability, and both models can deliver that if identity is handled deliberately. The next control dimension is reachability, because automation that can't reach machines can't control them, and the reason it can't reach them matters. Script-only approaches depend on network reachability at the moment you run the script, so a temporary routing issue, firewall change, or name resolution glitch can block the entire operation. Agent-based approaches can sometimes be more resilient because the agent can maintain a stable outbound relationship to the controller, which may work in environments where inbound management paths are tightly restricted. That difference can be a big deal for mixed networks and segmented environments, because inbound access is often treated as more dangerous than outbound. On the other hand, agent-based control can still fail if the agent service is down, if it can't reach the controller, or if local resources are too constrained for it to operate. The practical lesson is that reachability is not only about can I connect, but about what network assumptions does my control model require. Reliable operations chooses an approach that fits the access boundaries the organization actually enforces. Observability is another major difference, and it matters because control without visibility turns into blind pushing of changes. Agent-based systems often excel at telemetry because the agent can report state regularly, not just when you run a job. That can give you a clearer picture of drift, failures, and compliance posture, and it can help you detect problems before users complain. Script-only systems can still be observable, but they often collect information only during a run, which can leave gaps between runs where important changes happen unnoticed. Beginners sometimes think logs are enough, but operational control improves when you can answer questions like which machines are out of compliance right now and which ones are failing their last enforcement cycle. Agent-based systems can provide that always-on feedback loop more naturally, while script-only systems tend to require scheduled checks and careful log aggregation to get similar visibility. The trade-off is that continuous visibility depends on the agent being healthy and trusted, which adds operational responsibility. Control includes not only actions, but awareness, and that's where these models diverge. Drift detection and remediation highlight the control difference in a very practical way, because drift is what turns clean plans into messy reality over time. Agent-based automation often supports a pull model where each machine periodically checks in, evaluates whether it matches the desired configuration, and corrects itself if needed. That can be powerful because enforcement happens close to the machine, and it can continue even when central orchestration is busy or intermittent. Script-only approaches commonly use a push model where a controller runs scripts against targets on a schedule or when triggered, which can work very well, but tends to be more dependent on central timing and central reachability. The control question becomes whether you want machines to self-correct continuously or whether you want the controller to drive correction at specific times. Beginners sometimes fear continuous correction because it feels like the system is changing itself, but when governed properly, it can actually reduce incidents by keeping baselines stable. The key is to ensure remediation is predictable, minimal, and auditable in either model. Change coordination is another area where control can feel very different, especially when multiple teams share an environment. With script-only automation, a central controller can enforce sequencing and rate limits across a fleet, which helps prevent thundering herd behavior where too many machines change at once. Agent-based automation can also coordinate changes, but it often requires careful design so that thousands of agents don't all apply a heavy update simultaneously just because a new policy became available. In practical operations, coordination matters because load spikes, dependency limits, and maintenance windows are real constraints, not theoretical ones. Script-only control can make coordination more explicit because the run is a scheduled event, while agent-based control can make coordination feel more distributed because each machine participates on its own cadence. Neither is inherently better, but the operational outcome differs. Centralized runs can be easier to reason about, while distributed enforcement can be more resilient to partial failures. The right choice depends on whether your environment benefits more from tight, centralized orchestration or from decentralization that continues working when parts of the system are degraded. Security posture also shifts with the model, and beginners should treat this as a design decision rather than as an afterthought. Agents increase the software footprint on every managed system, which means you must patch, monitor, and secure that component just like any other workload. If an agent is compromised, it can become a powerful control channel, so hardening, integrity verification, and least privilege are critical. Script-only automation reduces resident footprint, but it can increase reliance on remote access pathways and centralized credential stores, which can concentrate risk in the control plane. If a central runner or credential store is compromised, the attacker may gain broad power quickly. Control is about who holds the keys, and agent-based and script-only approaches place those keys in different places. A mature approach focuses on minimizing blast radius, improving auditability, and ensuring there is a clear revocation path when something goes wrong. When security is designed into the model, automation becomes a stabilizing force rather than a hidden vulnerability. Performance and resource overhead are often overlooked by beginners, yet they matter because control systems must coexist with production workloads. An agent consumes some amount of memory, processing, and storage, and it may also generate network traffic for check-ins and reporting. In small environments, this overhead is usually negligible, but at scale it can be meaningful, especially on constrained systems or in environments where every background process is scrutinized. Script-only approaches can have lower steady-state overhead because nothing runs persistently, but they can create bursts of load during execution, such as spikes of remote sessions, simultaneous package updates, or mass configuration checks. Those bursts can be disruptive if not paced carefully. The control trade-off is between continuous, low-level background activity and scheduled, higher-intensity activity. Practical operations often prefers predictable patterns, so whichever model you choose, you want to understand how it consumes resources over time and how it behaves during peak change events. Reliable automation respects system capacity, not just functional correctness. Another control factor is offline and degraded mode behavior, because real fleets are not always neatly online and reachable. If a machine loses connectivity to the controller, an agent-based system might still apply local policy if it has cached instructions, or it might at least maintain local enforcement of certain baselines until it reconnects. Script-only systems generally cannot act if they can't reach the machine, which means remediation and configuration updates may pause until connectivity returns. That can be acceptable in some environments, but risky in others where machines frequently move between networks or where remote reachability is intentionally limited. Beginners sometimes assume the network is always stable, but operations assumes the network will be unstable at the worst possible time. The control question is whether you want some enforcement capability to live with the machine or whether you want all control to live centrally. Degraded mode control is not about perfection. It's about having a safe, predictable behavior when ideal conditions are not present. When you plan for degraded mode, you reduce surprises during incidents. Troubleshooting workflows differ as well, and the difference affects how quickly you can restore service when automation behaves unexpectedly. With agent-based systems, you often have more local diagnostics because the agent can provide status, last-run results, and state information directly from the machine's perspective. That can make it easier to tell whether a failure is due to local conditions like a disk issue, a permission change, or a service dependency. Script-only systems often provide strong, centralized logs of what the controller attempted, which can help you compare behavior across many machines quickly, but may provide less local detail unless you explicitly collect it. Beginners sometimes get stuck when a remote run fails and they don't know whether the command never executed or executed and failed silently. And that ambiguity can be reduced when the control channel provides clearer state reporting. The operational outcome you want is fast root cause isolation. Is this a fleet-wide control plane issue or a local target issue? Agent-based approaches often make local state more visible, while script-only approaches often make orchestration intent more visible, and the best teams design logs and telemetry to cover both. Compliance and governance are also shaped by this choice, because control must be demonstrable, not just assumed. Many environments need to prove that certain configurations are enforced, that changes are tracked, and that exceptions are controlled. Agent-based systems often align well with continuous compliance because they can continuously assess and report posture, which creates a steady stream of evidence. Script-only systems can provide strong evidence during runs, but you may need to design periodic assessments to avoid long gaps between proofs. The control question is whether your governance model expects continuous assurance or event-based assurance, and how much effort you want to invest in building that assurance pipeline. Beginners sometimes think governance is something you add later, but operationally it's easier when control mechanisms produce evidence naturally. At the same time, continuous evidence must be protected because telemetry can reveal sensitive details if not handled properly. Good governance balances visibility with data protection, and that balance is part of the control design, not a separate concern. In many real operations environments, the most practical answer is not purely agent-based or purely script-only, but a deliberate hybrid that uses each where it provides the best control. An organization might use agent-based enforcement for baseline configuration and drift remediation, because that benefits from continuous local presence, while using script-only runs for special tasks, migrations, or one-time operations where installing an agent is unnecessary or undesirable. A hybrid model can also provide resilience, because if one control pathway is temporarily unavailable, the other may still function. The risk with hybrids is inconsistency, where different parts of the fleet are governed by different rules and nobody can explain which control applies where. That risk is solved by standardizing principles, such as identity governance, audit expectations, and change coordination, even if the execution mechanism differs. For beginners, the key is to view the model choice as a control architecture decision, not as a tool preference. When you architect for control, the mechanisms become easier to justify, document, and operate. To close, comparing agent-based automation and script-only automation is really about deciding how you want control to behave over time, especially when conditions are imperfect. Agent-based approaches tend to provide continuous visibility, local enforcement, and resilience to certain connectivity patterns, but they add a managed software footprint that must be secured, monitored, and kept consistent. Script-only approaches tend to reduce resident footprint and can provide clear centralized orchestration events, but they rely heavily on remote reachability and can concentrate risk in centralized credentials and control systems. Both can be designed to support least privilege, auditable change, and safe reruns, but they achieve those outcomes through different operational mechanisms. The practical skill is choosing the model that matches your environment's connectivity realities, governance needs, and failure modes, while designing guardrails that prevent either approach from becoming a brittle single point of failure. When you make that choice deliberately, your automation becomes more controllable, more predictable, and easier to trust at scale.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.